Hello, this is your review for your first test. We're going to start by categorizing numbers. So first let's look at what integers are. Integers are numbers including the opposite, so the negative numbers. They go in both directions. Natural numbers are counting numbers, so they start at 1 and they go up. Rational numbers are numbers that can be written as fractions. Whole numbers start at 0 and go up. Irrationals are anything that aren't rational, so it can't be written as a fraction. So our example is pi or square root of 5, since 5 can't be broken down into a perfect square. Imaginary numbers are when you have a negative inside of the square root sign. So when we look at 2.5, we know right away that it's not going to be an integer, whole, or natural, because those aren't allowed to have decimals or fractions, which means it's going to be a rational number. If it's rational, then it's not going to be irrational, and it's not imaginary because there's no negative underneath that square root sign. When we've got a negative 10, we can eliminate whole, we can eliminate natural, but that is going to be an integer. And I can write it as a fraction because I can put negative 10 over 1, so it's an integer and it's rational. Number 3, square root of 9. Don't automatically jump to the irrational category, because in this case, square root of 9 is equal to 3. So since that's a perfect square, even though there's a square root sign, it is going to be an integer. It is going to be natural because it's above 0. It's going to be whole. So we've got natural, whole, integer, and we can write it as a fraction by putting 3 over 1. So that's also going to be rational. Now when we look at the square root of 8, that's not a perfect square, that's about 2.83, and that's rounded, which means that the only category it's going to fall into is the irrational category. Moving on, our order of operations. Just remember your PEMDAS. It's parentheses, exponents, and then multiplication and division left to right, and then addition, subtraction left to right. So when we look at our first example, parentheses. We have parentheses here, so the first thing that we're going to do is add 3 plus 4 to get 7. After that, we have exponents. So we're going to evaluate 7 squared, because only the 7 is being squared, they're not the negative 2. So that's negative 2 times 49 plus 20 divided by 4. Then we have multiplication and division. Now we have multiplication here and division there. We go left to right, so we've got a negative 2 times 49, which is a negative 98. And then we evaluate our division. 20 divided by 4 is going to give us 5. And our answer is a negative 93. Number 6, we're going to evaluate using substitution. So remember, when you substitute in, you're going to use parentheses. So we've got a negative 3 minus 3 raised to the y, which is 2, all over 2 parentheses y minus a negative 3. So inside here, we've got a parentheses, a negative 3 minus 3 is going to give us a negative 6 on top. All of that's being squared, including the negative. On the bottom, we're subtracting a negative 3, which means we're really adding 3, so that's really 2 plus 3. So that's 2 times 5 on the bottom. That gives us 36 on top, 10 on the bottom. Make sure that you reduce your fraction all the way to 18 over 5. Alright, number 7, solving the equation. We are solving an absolute value equation. When you solve the absolute value, you kind of drop the absolute value signs, and we've got 4x minus 1 equals 2. That's going to be one of your equations. You've got a second equation. You take that 4x minus 1 and you set it equal to a negative 2. The absolute value signs are going to get rid of that negative sign from the inside. So that number on the inside could be a positive 2 or a negative 2, because the absolute value of 2 gives you your answer of 2. The absolute value of a negative 2 also gives you an answer of a positive 2. So this whole quantity inside could either equal the positive 2 or the negative 2. So we move our 1 over to get 4x equals 3, divide by 4, and one of our answers is x equals 3/4. Move the 1 over, we've got 4x is equal to a negative 1, divide by 4, and x is a negative 1/4. So you've got two answers that are going to make that true. Number 8, when we simplify the expression, don't overcomplicate this. All this is combining like terms. When you combine like terms, the very first thing you want to do is get rid of any parentheses. So we've got to distribute the 5x in. 5x times x is 5x squared. 5x times a negative 3 is a negative 15x. Nothing's happening to the 4x squared, so we just add 4x squared. And then we have to distribute the negative 3. Make sure that you're distributing the negative with the 3 as well. So that's a negative 3x and a negative 6. Once you've gotten rid of all of your parentheses, now it's time to combine like terms. So we've got 5x squared and 4x squared. That gives us 9x squared. A negative 15x and a negative 3x is a negative 18x minus 6. You only had one number term. So remember, same exponent, same variables, what's going to define like terms. Alright, move it on to the back page of your notes. Okay, we're talking about matrices now. If we are solving for a missing variable, first look to see what operation you're doing. Here we are adding the matrices. When you're adding the matrices, you're adding the corresponding entries. So if I want to solve for x, that's top left, I'm looking at all the top left numbers. So I've got 2x plus 6 is equal to 10. Move the 6 over, 2x equals 4. Divide by 2, and we've got x is equal to 2. If we're looking for y, y is in the bottom right. So I'm going to use all the bottom right entries. I've got 5 plus y is equal to 2. Move your 5 over, and you've got y is equal to a negative 3. Remember, it's very important on your test that you show me these setups and you show me how you get those numbers. Even though you may be able to do it in your head, I need to see where the numbers are coming from. Number 10, now we're multiplying matrices, and multiplying matrices gets a little bit more difficult. When I want to solve for x, that's in column 1. Remember, the rows come from the first matrix and the columns come from the second one. So if I want to solve for x, I look at my answer. I could use row 1 because it's a number. I could use row 2 because it's a number. I would not use row 3 to solve for x because I have a second variable there. So let's just use row 1, and we only have one option for our column. So we multiply negative 2 times 1 to get a negative 2. 1 times x, which is x. 2 times 3, which is 6. And row 1, column 1, we set that equal to 6. So we've got x plus 4 is equal to 6. Move the 4 over, and we find that x is equal to 2. Now when I'm solving for y, y's location is row 3, column 1. So I must multiply row 3 and column 1 together. I'm not going to have two variables because that x is really a 2 that we just found out. So it's 0 times 1, which is 0. Negative 2 times 2, which is a negative 4. 4 times 3, which is 12, equals y. And that means that our y is equal to 8. Just like the addition matrices, we want to make sure that you show the setup and the answer so that you can get full credit for those questions. Next, talking about the dimensions of matrices. When we look at A, we've got 3 rows and 3 columns, so this is a 3 by 3 matrix. When we look at B, we've got 2 rows and 3 columns. All the question is asking you for is what are the actual dimensions if you were to find AB. I'm not asking you to find A times B, I'm just asking what the dimensions would be. So we've got a 3 by 3 times a 2 by 3. And if you look at the middle numbers, that means you can't actually multiply. So the dimensions would not actually exist. If I were to do B times A, our B would come first, would be a 2 by 3 times a 3 by 3. Now that our middle numbers are the same, our answer matrix would be a 2 by 3. And 13, if I were to add a and b, I would have a 3 by 3 plus a 2 by 3, and you can't add these either. Remember, in order to add, your dimensions must be exactly the same. So this would have to either be a 2 by 3 and a 2 by 3, or a 3 by 3 and a 3 by 3. Alright, we're almost done. Now we've got our compound inequalities and our absolute value inequalities. We want to solve and graph. So we want to isolate our x, we move the 5 over. We've got a negative 2x is less than a negative 4. We divide by a negative 2 on each side. Since we're dividing by a negative, we've got to flip that less than to a greater than. A negative divided by a negative is a positive 2. Divide by 6, and x is greater than or equal to 3. Make sure that your numbers are in the correct order on your number line. Since it's greater than 2, we've got an open circle to the right, greater than or equal to 2 or 3 to the right. And since we have an AND graph, that means that we are looking for the overlap. What do both of them share? So they're overlapping here. They both have the number 3, so we've got a closed circle to the right. Number 15, we are solving an absolute value inequality. So just like when we solve the absolute value equation, we've got to set up two pieces. So I've got 3x plus 2 is greater than 4. And when I set up the other one, 3x plus 2, not only do I change it to a negative 4, but I've got to flip the sign from a greater than to a less than symbol. We move the 2 over, 3x is greater than 2, divide by 3, and x is greater than 2/3. Move the 2 over, 3x is less than negative 6, divide by 3. Now we don't flip this time, even though there's a negative in the process, the number that you divide by has to be negative in order to have to flip. So x is less than a negative 2. Now in our number 14, we were given the word AND. When we look at absolute value inequalities, we have to look at the sign. Since this is greater, this is going to be an OR problem. If it was less than, it would be an AND problem. So we graph our inequalities. Negative 2 is smaller than 2/3, so make sure that goes to the left. Greater than 2/3, open to the right. Less than negative 2, open to the left. And our OR graph means that we combine both. So we're going to recopy on a third level. And remember, for full credit, you must have 1, 2, 3 levels, unless it's a special case range when you can go directly to your answer. Alright, last but not least, do not forget to look over your word problems from your notes and your homework, especially those Lin-Reg word problems. Alright, you are all set and hopefully you're ready for your test tomorrow.